Hey there, astronomy students. This is Ms. Ruark, and we are starting out with our fantastic year of astronomy here. This is going to be a year full of fun, but in order to have the fun, we have to do the work first. So let's get to work. In this vodcast, this is our first vodcast. You've already been explained how to do this in class, so what we're going to do is we're going to look at conversions. Using your fill-in-the-blank notes, let's go. All right, so metric conversions, what are they? Well, there's a difference between the metric system and the English system. You've grown up in this great country of the United States learning about the English system. Now, the metric system was introduced and it is used in some instances, which we'll talk about in just a moment, but for the most part you use the English system. Well, what is the English system? It's a system of historical units of measurement that was started back in England and was used through 1824. And then in 1824 they redefined some of the units. A lot of the units went away and the names went away, but some of them still remain today, which are the ones that we're familiar with. And they're listed there: inch, foot, yard, mile, acre, teaspoon, tablespoon, cup, pint, quart, gallon, bushel, ounce, pound, ton. This is mostly used in the United States of America. I believe Liberia, Burma, and then some English items are measured still using the English system. However, the majority of the world uses the metric system. So what is the metric system? Well, it's something that is a set standard of measurement. It's accepted all around the world. So here it says instead of the king's foot. Well, back in England, they used to use the king's foot to measure length. Well, I don't know about you, but if I was awarded land given by the king's foot, and the king was a short man with a little foot, and then my younger sister comes along and gets awarded land by the next king who happens to have a really big foot, I'm going to be mad, especially if I get 10 king's foot and she gets 10 king's foot. She's going to get more than me. That's not going to make me happy. I want this to be standard. So they came up with the metric system. It's based on a power of 10, and it uses prefixes to designate the power of 10 for those base units. So what are the base units? Well, for distance we measure in meters with little m as the symbol. Mass is in grams with a little g. Time is in seconds with just an S, not SEC. That's Southeastern Conference, completely different thing. And then volume is in liters, and that's a capital L because a lowercase l looks like a 1. All right, so our prefixes. Now you've probably all heard the saying, King Henry died by drinking chocolate milk. And if you haven't, well, there you go, because I'm going to use that saying with you. There's a couple other ones we could use as well, but King Henry died by drinking chocolate milk. King, K for the kilo, H for hecta, D for deca, B, the by, stands for your base units. Your base units are going to be meters, grams, seconds, liters. There's others. D for deci, C for centi, and M for milli. Now these over here, these are all big prefixes, and these are all small prefixes. All right, so for example, for meters, we would have kilometers or kilometers, hectometers, decameters, just meters, decimeters, centimeters, and millimeters. Now, a lot of people get confused with the M for meters. They think that well, they think if I'm asking you to go to millimeters, they'll go to here. Or if I'm asking just to go to meters, they'll go to here. You can't do that. It has to have the prefix in front of it. So if it's just a letter by itself, it goes under base units. If it's a letter with something in front of it, or a letter with something behind it, then you look at the first letter, and that determines which one it falls under. Okay, and we'll practice this in class. Okay, well, how about we practice right now? Okay, so on your paper you have these. If you know how to do this, go for it and check your answers. If you don't, follow along with me. All right, if we have 15 meters, so we're starting here, and we need to go to km. So we're going to go over here to k. I'll put a star there. Okay, well, we're going to have to move our decimal from here over 1, 2, 3 times. Okay, we're going to move the decimal 3 times. And what direction did we go? We went to the left. So we're going to move our decimal 3 times to the left. Well, 15 doesn't have a decimal. So if there's no decimal there, we assume that the decimal is at the end, just like a period would be at the end of a sentence. Okay, so we take that decimal and we move it over 1, 2, 3 times. Don't count 1, 2, 3, 4. Don't count the number of tops that you have. Count the number of humps or troughs that you have. You have 1, 2, 3 troughs, so you're going to move it 1, 2, 3 times. So that ends up giving you 0.015 kilometers. All right, go ahead and try the next 3. Go ahead and pause it. Try the next 3 and come back and check your answers. Oops. Okay, so let's check our answers and see how we did. So with this next one, and if you're not sure, I'm going to go ahead and just give you the answers and you can check them. And if you're not sure, then you need to come talk to me in class tomorrow. All right, so 1.6 kilometers is the same thing as 1,600 meters. If any of you run track, that number, 1,600 meters, might sound familiar. All right, 0.10142 hectometers is equal to how many decimeters? And you should have 14.2. Okay, and then for the last one, 0.00579 decameters. Notice it's a big D for deca, little d for deci. All right, is equal to how many millimeters? 57.9. All right, if you got these all right, you should be jumping up and down in your room, woo, 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 throwing a party right now. And if you didn't, don't worry, because we're going to be throwing that party for you in class. Okay, moving on. Common units in astronomy. We have light years, astronomical units, parsecs. You will also see kilometers. And then the last one, not common for astronomy, but common for us, and you will hear this one, is miles. So the light year is LY, that's the abbreviation, and it's the distance that light travels in a vacuum in 1 Julian year. We'll get into that in class. All right, so these are all units of length, and 1 light year is equal to 10 raised to the 13th kilometers. And that's the same thing as 63,000 astronomical units. Well, why does that mean anything, Mr. Dark? What in the world is an astronomical unit? Well, let's look at that. Astronomical unit. Abbreviation is AU, unit of length, and it's roughly the distance from the Earth to the Sun. Now, the Earth goes around the Sun, and it doesn't go in a perfect circle. It's kind of close, but it doesn't go in a perfect circle. So that's why it's roughly the distance from the Earth to the Sun. So it's the average distance. And we say that 1 astronomical unit is equal to 1.5 times 10 to the 11th meters. That's huge. That's a huge number. You should know that. And if you don't, I'll show you in class, because we're going to do a big thing on scale. All right, next we've got parsecs. A parsec, PC, is another unit of length, and 1 parsec is equal to 3.3 light years. Okay, it's really far. It's even further. All right, and then the mile, the unit of length, 1 mile is equal to 1.609 kilometers, which is the same thing as 1,600 meters. Oh, track people. So if you run the 1,600, you're running 4 times, right? And you're running 1 mile. Oh my gosh. That's a long distance. I know we can't do that. All right. Conversion factors. So how do we convert from one unit to the next? Well, we know that 1 dozen of anything is equal to 12. So if you go to the store and get a dozen eggs, you get 12 eggs. If you go to the store and you get a dozen bagels or a dozen donuts, you get 12. We also know that 12 inches is equal to 1 foot. And we know that 3 feet is equal to 1 yard. So these are all conversion factors because you can set them equal to 1 and use them, be rearranged to equal to 1 to change units from one to the other. So what do I mean by that? Well, we put them into a fraction. So we could say that 12 inches is equal to 1 foot. 12 over 1, they're the same thing, so they cancel out and they equal 1. Or 1 over 12 equals to 1. Okay, so we use those to convert from one unit to the other. All right, so let's do an example. Since this is football season, after the snap, a quarterback hands the football off to the fullback, and he carries the ball 5.7 yards up the field. Whew! First down. Woo! We're excited. Everybody's yelling, and then they blow the whistle, right? All right, how many inches does the football travel? Inches? We don't care about inches. Well, we do right now. Okay, so you're always going to start with the number that they give you in the problem, which just so happens to be 5.7 yards. You're going to start with that, and you're going to multiply it by conversion factors to end up getting your answer. Okay, so here we do 5.7 yards. We multiply it by this conversion factor, which happens to have the unit we want to get rid of on the bottom. 1 yard is equal to 3 feet. Where did I get that from? That conversion factor right there. Okay, so yards have canceled, and now we're at we have feet, but we don't want feet in our answer. We want inches. So we've got to go from feet to inches. Well, we put feet, lead with your units, we put feet on the bottom. And we know that feet and inches, 1 foot is equal to 12 inches. Well, where did we get that? Right there. Oh. All right, feet cancel, we're left with inches, and inches will be in our answer. So now we just have to do the math. So I know there's a bunch of junk in the way you can't see it anymore, right? Let me erase all that. All right, so to do the math now, we say that 5.7 times 3, you can divide by 1 here if you want, times 12, divide by 1 again, and that gives you 205.2 inches. That's pretty easy, right? Of course it is. And we're going to do lots of practices in class. Instead of me sending you home with that practice, we're going to do it in class. All right, so let's practice. All right, the first one we're going to do, planet Z is 0.58. This is a fictional planet. It's not real. Okay, 0.58 times 10 to the 8th kilometers from the sun. What is that distance in AUs? What's AUs again? Not Auburn University's. Okay, I'm really not that funny, but I think I'm hilarious, so you'll just have to deal with it. All right, so what is the distance in astronomical units? All right, we need to start with this number here, and this is what we're trying to find. So we're going to start with that number, and we're going to put that down first. We're going to multiply it by a conversion factor. What conversion factor, you might say? Well, the ones I gave you that are in your notes now. So 0.58 times 10 to the 8th kilometers. Notice I take this unit and I automatically put it on the bottom, and I put the unit that I'm looking for on top. And then all I have to do, going back to my notes, is I write in the numbers that go with it. So from our notes, we know that 63,000 astronomical units are equal to, that's kind of what that division line is, 10 to the 13th kilometers, which gives us 0.03654 astronomical units. Okay, and if we're going too fast, remember, nice thing about this is you can always pause it. You can rewind it, you can watch it again. Oh yeah. All right, next one. Ooh, no, I don't want to do that. A fuzzy green alien travels for 3.5 light years to arrive on Earth. How far did it travel as measured in kilometers? So we've got 3.5 light years, and we are looking for the answer in kilometers. So pause it, set it up, come back and check and see if you've got it right. All right, 3.5 light years, because 3.5 is 3.5. We take light years and we put it on the bottom. We're solving for kilometers. Light years cancel. Kilometers in our answer. There you go. All right, one more. Maybe. Yes, here it is. All right, that same fuzzy green alien leaves Earth and travels for 1/2 of a light year, 0.5, right? How far did it travel measured in AUs? Okay, pause it, try it, come back and check your answer. All right, so we put 0.5 light years. Light years goes on the bottom so that they cancel. Astronomical units, that's what we want to know. So we do the math, and you should get that for your answer. Okay, if you're unsure about this, don't worry. I'm giving you the foundation. We are going to come back together, and we're going to practice a lot of these in class for a couple days. Okay, here's a little something to leave you with. Don't be scared of numbers. See you in class.